Tutorial Garden Path VisualLISP IDE. Attention! This tutorial requires the VisualLISP editor and applies to Windows only. Overview. Your goal in this tutorial is to develop a new command for AutoCAD that draws a garden path and fills it with circular tiles. The tutorial is divided into 7 lessons. This tutorial covers the VisualLISP environment is introduced. This environment provides you with editing, debugging, and other tools specific to the creation of AutoLISP applications. ActiveX and reactive functions of AutoLISP are demonstrated, as well as several other extensions to AutoLISP language provided with VisualLISP. There are 2 possible execution contexts for this tutorial. The application may be run as interpreted Lisp in piecemeal files or functions that are loaded into a single document, or the program code can be compiled into a VLX application denoted by a star.VLX executable. A VLX operates from a shell-contained namespace that can interact with the application loading document. Lessons. Note: as you progress from lesson by lesson, you receive progressively less detailed instruction on how to perform individual tasks. Basic. Lesson 1. Designing and beginning the program. Intermediate. Advanced. Assumptions. This tutorial assumes that you are familiar with Lisp and AutoLISP. It also assumes that you understand basic Windows file management tasks such as creating directories, copying files, and navigating through the file system on your hard disk or network. Sample files. If you choose the full installation option when you install AutoCAD, the source code files are in the following directory: AutoCAD directory, tutorial, VisualLISP. It is recommended you do not modify the sample source code files supplied with AutoCAD. If something is not working correctly within your program, you may want to copy the supplied source code into your working directory. Throughout the tutorial, the working directory is referred as AutoCAD directory, tutorial, VisualLISP, my path. If you choose a different path for your working directory, substitute your directory name at the appropriate times. So we're going to go to the basic lesson, designing and beginning the program. Lesson 1. Designing and beginning the program. VisualLISP IDE. Attention! This lesson requires the VisualLISP editor and applies to Windows only. In this first lesson, you will begin by defining what the application will do. Using the VisualLISP development environment, you will create a Lisp file and begin writing AutoLISP code to support your application. In the process, you will begin to discover how VisualLISP facilitates application development. First is defining overall program goals. Defining overall program goal. Developing an AutoLISP program begins with an idea for automating some aspect of AutoCAD. It may be a need to speed up a repetitive drafting function or to simplify a complex series of operations. For the tutorial, the garden path, you want your program to draw a complex shape with a variable number of components based on initial input from the user. Here's what it will look like. Your program must do the following to draw the garden path. Given a starting point and an end point and a width, and then you draw a rectilinear boundary. The boundary can be at any 2D orientation. There should be no limit on how large or small it can be. Prompt the user for tile size and tile spacings values. The tiles are simple circles and will fill the boundary but must not overlap or cross the boundary. Place the tiles in alternating rows. To see how things should work, you can run a complete version of the application that is supplied with AutoCAD. To run the supply example, click on Manage tab. Click on the Manage tab here. Go to Application panel. Go to Load Application. Select the GardenPath.VLX from Tutorial Visual Directory. So I'm gonna go to there. It's gonna be in. So I'm gonna come back to see where's the Tutorial Visual Directory. So it's in AutoCAD directory, Tutorial. It's gonna be in Tutorial and VisualLISP. It's gonna be in so VisualLISP directory, GardenPath VLX, and we'll load it. And then close. At the command prompt, you enter gpath. Respond to the first two prompts by picking a start point and an end point in the AutoCAD drawing area. So you put one here, start point and end point. Enter 2 at half width of path prompt. So we're gonna put in here 2. Click OK when prompted by the GardenPath tile specification dialog box. So we're gonna radius tile, spacing between tile, active automation, line width. We click it, and you're gonna get this. So that's the automation that already done for us. So that is the overall programming goals. Next is getting started with VisualLISP. Getting started with VisualLISP. Now that you have seen how the application is supposed to work, you can begin developing it with VisualLISP. But first, it helps you to demonstrate what can happen when VisualLISP is waiting for control to return from AutoCAD. You may have already encountered this. To see VisualLISP wait for control to return from AutoCAD, you click on Manage tab, Application panel, Load Application again, and you select GardenPath VLX, and then you click Load, and then click OK, close. At the AutoCAD prompt command, you enter VLISP to start VisualLISP. So you're gonna VLISP to start VisualLISP. Switch back to the AutoCAD window. Either select AutoCAD from the task or press tab to choose AutoCAD. Enter. So we're gonna AutoCAD VisualLISP. We're gonna start AutoCAD VisualLISP. So we need to restart AutoCAD. So we start AutoCAD again. We're gonna just create a new drawing, and we just put it in the side there. That's interesting. The shortcut key is not work for me. I'm gonna go to Manager, Load Application, load the GardenPath.VLX, and type in VLISP, and the VisualLISP for AutoCAD is gonna be start. It looks like that. So getting back to AutoCAD command, and then type in gpath. Before responding to the prompts from gpath, switch back to the VisualLISP window. So I'm gonna have that here, and the VisualLISP should be up there. So back to VisualLISP window. In the VisualLISP window, the mouse pointer appears as a VisualLISP symbol, and you cannot choose any commands or enter text anywhere in the VisualLISP window. The pointer symbol is a reminder. It's a reminder that there is an activity you must complete in AutoCAD before resuming work with VisualLISP. Remember this whenever you see the VisualLISP pointer. That is the VisualLISP pointer. We can see that. Now you are ready to begin building the GardenPath application. To begin application development with VisualLISP, from the VisualLISP file menu, you click a new file. So you need to come back to AutoCAD, and you need to cancel that, and then you can come back to VisualLISP. So now you can go to here and create a new file. So you enter the following code in a text editor window. It is the window title untitled 0. You can omit the comments if you wish. So we got function cgraph is the main program function and defines the autograph command. So defun C is graph, that function. You're gonna ask the user for input first for path location and directory, then for path parameters, and then continue only if you have valid input. So if GP get point input, if GP get dialog input, and at this point you have valid input from the user. Draw the outline, storing the result polyline pointer in the variable called polyline name, and then you set Q the polyline name GP draw outline, and then you're gonna print that GP draw outline function return and polyline name. Then print that, and then put an alert, congratulations, your program is complete. And then you close this, and then print out function cancel or incomplete information to raw boundary, or exist quietly, or display a message to let user know the command name. Type in ggraph to draw a garden path and print C. That means print to screen, I think so. So that is the application. You choose save as, and save as on the menu, and save the code in the new file as AutoCAD directory my path. So it's in inside AutoCAD directory, inside there, inside AutoCAD, inside tutorial, inside VisualLISP, inside my path. I'm gonna put in gp main.nslsp, which is a Lisp file. So it not allow you to save in here. So something you don't have the admin right to save in here. So what I'm gonna do, I'm gonna close this, close the AutoCAD. No, saving that. I'm gonna run. So AutoCAD, I'm gonna run as administrator, and that one I'm gonna create a new drawing. I'm gonna turn on the VisualLISP editor, and inside VisualLISP editor I'm gonna just create a new file. Just copy the code and copy and paste it in the program file, Autodesk, AutoCAD, tutorial, inside VisualLISP, inside my path, which is called gp main.lsp, and it's okay now. So that is the difference between running as an administrator and running as a normal user. So then now we finish that. You're gonna close it and close it, and we get back to the third part, is looking at VisualLISP code formatting. So I think in order to make the clip short, I'm gonna make it here as tutorial garden path VisualLISP IDE Lesson 1, designing and beginning the program VisualLISP IDE. 3. Looking at VisualLISP code formatting. VisualLISP recognizes various types of characters and words that make up an AutoLISP program file, and highlights the characters in different colors. This makes it easier for you to spot something incorrect quickly. For example, if you miss a closing quotation mark following a text string, everything you type continues to display in magenta. The color denoting strings when you enter the closing quotation mark. VisualLISP correctly color the text following the string according to the language element it represents. As you enter the text, VisualLISP also formats it by adding spacing and indentation. To get VisualLISP to format code, you copy into its text editor from another file. Choose to format code in editor from the VisualLISP menu. You can click on that, format, check selection. So I'm gonna check that, check done, all good. So that's the way you can do that. So that is LetVisualLISP code formatting. So that's it for tutorial guidance path VisualLISP IDE lesson 1, designing and beginning the program. VisualLISP IDE, looking at VisualLISP code formatting. Tutorial guidance path VisualLISP IDE lesson 1, designing and beginning the program. Analyzing the code. The define function statement defines the new function. Notice the main function is named CGPath. The C prefix establishes that this function is capable from the AutoCAD command line. GPath is the name users enter to launch the program or the application from AutoCAD command prompt. The functions that obtain input from users are named to GP:"GetPointInput and GP:"GetDialogInput. The function that draws the guidance path outline is GP:"DrawOutline. These names are prefixed with GP to indicate that they are specific to the guidance path application. This is not a requirement, but it is a good naming convention to use to distinguish application-specific functions from general utility functions you frequently use. In the main function, print C display the result of the program if it runs successfully, or a warning message if the program encounters an unexpected event, so which is here. For example, as will be seen in lesson 2, if the user presses enter instead of picking a point on the screen, the code to GP:"GetPointInput ends prematurely, returning a nil value to the main function. This causes the program to issue a print message, incomplete information to draw a boundary. So if in here, so this here, if GetPointInput is not working, you're gonna print out this one, incomplete information to draw a boundary. The code to print near the end of the program serves as a prompt upon application load. So again, the code to print C near the end of the program will serve as a prompt. Upon application load, the prompt informs user what they need to type to initiate the drawing of a guidance path. The final print C without a string argument forces the program to exist quietly. So here, this one will exist quietly, and this one will inform user that incomplete information to draw a boundary. So if the final suppressing pin C were omitted, the prompt would display twice. So that the content of the code. And that's it for lesson 1, designing and beginning the program, analyzing the code. Tutorial guidance path VisualLISP IDE lesson 1, designing and beginning the program. Filling the gaps in the program. Filling the gaps in the program. So for the code in this new file to work correctly, you must write 3 more function definitions. The main guidance path code contains code to 3 custom functions: GP:"GetPointInput, GP:"UserInput, and GP:"DrawOutline. For now, you will just write stubble out function definitions. A stubble out function serves as a placeholder for the complete function that is to follow. It allows you to try pieces of your code before adding all the detail needed to complete the application. To define stoppable L functions for the application, position your cursor at the top of the program code in the text editor window and press enter a couple of times to add blank lines, and enter the following code beginning where you insert the blank lines. So you're gonna go back there. I'm gonna copy this and we put in there. So right before the end of each function is a line of code that contains only a T there. So this is used as a return value to the calling function. All AutoLISP function returns a value to the function that call them. The letter T is a symbol for true in AutoLISP, and adding it calls the function to return a true value. So we can see here T and T. I was thinking of using Notepad for demonstration. So here copy that one into this. Actually I'm not saving, but because I think in order to demonstrate, I think this is probably good for me to do that. So I think here I'm gonna choose style configure. I'm gonna choose the default style. I'm gonna save and close. So here I got it's gonna be easier. Maybe that style is not very nice. I'm gonna choose another style. So here right before the end, so we can see the T here. So we can do that. We can define a function there. That define a function. That alert will finish that part of the function. So that is the Lisp language. So everything need to be open and close brackets. So here the way GP main Lisp is structured, each input function is must return a value other than nil, which indicates no value, for the program to proceed to the next step. An AutoLISP function will by default return the value of the last expression evaluated within it. In the stoppable L functions, the only expression is to call the alert function, but alert always return nil. If this is left as the last expression in GP GetPointInput, it will always return nil, and you will never pass to the if to the GP getDialogInput function. So we got here the getDialogInput function. So we can get that to separate different function. I think so. So we set a function there, another function there, and do that. So we got different function. So for a similar reason, the end of GP draw outline here, function will return a code symbol called some ename as a placeholder. A code symbol is a Lisp construct that is not evaluated. If you are curious about how the Lisp language works, there are a number of good books available mentioned at the end of this tutorial. So we got alert, what's that? And that is for filling the gaps in the program. Lesson 1. Design and beginning the program. 6. Letting VisualLISP check your code. VisualLISP has a power feature for checking your code for syntactical errors. Use this tool before trying to run a program. You can catch common typing errors such as missing parentheses or missing quotation marks and other syntactical problems. To check the syntax of your code, make sure the text editor window containing GP main Lisp is in the active window. Click in the title bar of the window to activate it. From the WisWorldLISP menu, choose Tools and check Text Entity Editor. Tool and choose check Text Entity Editor. The build output window displays the results of the syntax check. If WisWorldLISP did not detect any errors, the window contains text similar to the following. Check done. If you have problems and need help, refer to Developing Program with WisWorldLISP section in the AutoLISP Developer Guide. See if you can determine where the problem is located. If you are spending too much time on locating the problem, use the sample gp main.lisp file provided in the lesson 1 directory to continue the tutorial. To use the supply gp.main.lisp program, if necessary, close the text editor window containing the gp main.lisp code you enter. Click File, Open File from the WisWorldLISP menu. Open gp.lisp file in the tutorial visual lesson 1 directory. Click on Save As and save in your tutorial WisWorldLISP my path directory as gp main.lisp and replace the copy you created. And that's it for letting WisWorldLISP check your code. Lesson 1 Design. Lesson 1 7 Running the program with WisWorldLISP. Running AutoLISP programs in WisWorldLISP allow you to use many debugging features of WisWorldLISP to investigate problems that may occur in your application. To load and run the program, with the text editor window active, click on Tools, Load Text in Editor from the WisWorldLISP menu. At the prompt in the WisWorldLISP console window, enter cgpath. The console window expects commands to be entered with AutoLISP syntax, so all the function names must be enclosed in parentheses. Then load the program. So with the text editor window active, Tools and Load Text in Editor from the Visual Text menu. So we got there in Tools, Load Text in Editor. Other prompt in the WisWorldLISP console, enter gpath, cgpath. The console window expects commands to be entered in AutoLISP syntax, so all function names must be enclosed in parentheses. So it's gonna be cgpath like that. Enter and click OK to respond to the message. The final message should congratulations, your program is complete. Function GetPointOutput will get user drawing input. Function GetDialogInput will get user choices to a dialog. This function will draw the outline of the polyline and return. This function will draw the outline of the polyline and return a polyline entity name and pointer. Congratulations, your program is complete. Note that if AutoCAD is minimized when you run gpath, you will not see the prompts until you restore the AutoCAD window using either the taskbar or Alt tab. So that's it for running the program with WisWorldLISP. Lesson 1 Designing and beginning the program WisWorldLISP. Lesson 1 8 Wrapping up Lesson 1. So in this section, you define program goals, learn the value of sub-functions, learn about naming functions to identify them as specific to your application or as general functions to be used over and over again, learn how to use WisWorldLISP to track your code, learn how to load and run a program in WisWorldLISP. You are done with this lesson. So your program again to be certain you have the latest revisions. So that's it for part 8 of lesson 1, wrapping up lesson for lesson 1, designing and beginning the program WisWorldLISP. Lesson 2, using WisWorldLISP debugging window tools, WisWorldLISP IDE. Attention! This lesson requires the WisWorldLISP editor and applies to Windows only. This lesson teaches you how to use several valuable WisWorldLISP debugging tools tools that speed up the development of AutoLISP programs. You will also learn the differences between local and global variables and when to use them. Your program will become more active, prompting users to enter some information. The information will be stored in a list, and you will begin to understand the power of using lists within your AutoLISP programs. After all, Lisp got its name because it is list processing language. Topic in this tutorial: differentiating between local and global variables, using local variables in the program, examining the GPGetPointInput function, using association lists to bundle data, putting association lists to use AutoLISP, storing the return value of GPGetPointInput in a variable, examining program variables, refining the program code, commenting program code, setting a breakpoint, and using more watches, using the debug toolbar, stepping through code, watching variable as you step through a program, AutoLISP, stepping out of the GPGetPointInput function and into GP main, wrapping up lesson 2. So that's it for overview of lesson 2 using VisualLISP debugging tool VisualLISP IDE. Lesson 2, part 1. Differentiating between local and global variables. This lesson discusses the use of local variables versus global document variables. Global variables are accessible by all functions loaded within a document or drawing. These variables may retain their value after the program that defines them completes. Sometimes this is what you want. You'll see an example of this later in the tutorial. Local variables retain their value only as long as the function that defines them is running. After the function finishes running, the local variable values are automatically discarded and the system reclaims the memory space the variable used. This is known as automatic garbage collection and is a feature of most Lisp development environments, such as VisualLISP. Local variables use memory more efficiently than global variables. So you got function A, set local variable, set local variable, set local variable, set global variable. Function B run that, print local variable, nil, print. Function C, print whenever, and come back here, print bool, print global variable whenever. Another big advantage is that local variables make it easy to debug and maintain your applications. With global variables, you are never sure when or in which function the variable value might be modified. With your local variables, you do not have as far to chase. You usually end up with fewer side effects, such as one part of the program affecting a variable from another part of the program. Because the advantages cited, this tutorial uses local variable almost exclusively. Note that if you have been working with AutoLISP for some time, you may have developed the practice of using global variables using development to examine your program while you are building it. This practice is no longer necessary given the powerful debugging tools of VisualLISP. So that's it for differentiating between local and global variables. Lesson 2, Part 1. Lesson 2, Part 2. Using local variables in the program. Refer to GPGetPointInput function you create in Lesson 1. You got define GPGetPointInput. You got an alert function GPGetPointInput will get the user drawing input. Then close the alert and for now return t as if the function will work correctly, and then t, and then finish the function. So far the function does not do much work. You will not begin to build on it. You will now begin to build on it by adding functions to get input from the user, which will define the start point, end point, and the width of the path. It is a good practice when creating AutoLISP programs to emulate the behavior of AutoCAD. For this reason, instead of asking the user to indicate the width by selecting a point in the drawing in respect to the center line of a linear shape, your program should ask for a selection of the half width. Once the GPGetPointInput function is complete, the variables as well as the values assigned to them will no longer exist. Therefore, you will store user supply variables in local variables. Here's what the function might look like. So you define the function get GPGetPointInput, and you put in the variable start point, end point, and half width, which is the input variable, input parameters. So if set start point, get point, start point a path, then if set end point, get point, and we're gonna start PT. So that's interesting that start PT, get point, start PT, and end point a path. If set point half width, get distance, end point half width of the path is true, then we have t is true there, and that's for closing. So I'm gonna check it in I think Notepad is pretty good in terms of checking, just for checking. So we got there. So you see that. So if that one, return that one, and then if that one, return that one. So we have some if function there. So the local variables are declared following the slash character in the define function statement that begin the function. The first call is to get point prompts the user to indicate a start point. The endpoint is then acquired in relation to the chosen start point. While selecting the endpoint, the user will observe the rubber band line extending from the start point. Okay, so that's why we put in here to get a rubber band. Similarly, while getting the half width value, the user will view another rubber band line, this time representing distances emanating from the endpoint. To see how GPGetPointInput works, you type in getPointInput code. You can type in this one in the Visual Console. So GP GPGetPointInput. So you need that GPGetPointInput. Okay, so function GPGetPointInput will get user drawing. That's done. So with the console window following the last parenthesis of the block of code or in the next line below, then press enter and you will replace any previous load version of the GPGetPoint function. So execute the function at the console will by entering getPointInput at the console prompt, and fix point when prompt enter the half width. So I think I need to, what I'm gonna do, I'm gonna change this by the define getPointInput. I need to change that. Gonna be different one. Save it. Now I'm gonna call GPGetPointInput again. So that will say something. GetPointInput will get user input. Now is this? It'll reload it.
So It's good practice when creating Lisp to emulate. Okay, so once again, once the GPU function is complete, the variable as well. Okay, so here we come back to here with the console. Okay, execute the function from the photo by entering at the console. So with the console window cursor following last parenthesis by the block of code. In the next line now, enter will replace previous load version. So we're gonna do this. Gonna put in that and we will enter. I think so. I think it's already loaded. I think we need to load it again. So we go to load text in editor. Yeah, after loading it, we can press start and run it. Okay, so now it's changed now. It will gonna access. So see, you're gonna access the start point of the path, and then it will access the end point of the path, and it will ask the width as well. Maybe we can define the width by just doing like that, and then it will exist. So it's running fine. So that is a function called getPointInput. That's very simple but effective, yeah, useful function. And that's it for using local variable in the program, which is part 2 of lesson 2 using VisualLISP debugging tool. Lesson 2, part 3, examining the GPGetPointInput function. When you ran the GPGetPoint function, control was automatically passed from VisualLISP to AutoCAD. You respond to 3 prompts, after which control was passed back from AutoCAD to VisualLISP, and a T-system display in the console window. Within the program, here's what happens. VisualLISP waits for you to pick the first point. When you pick the first point, the program stores the value of your selection. A list containing 3 coordinates, an x, y, z value, into the start point variable. The first if function examines the result to determine whether a valid value was entered or low value was entered. So this is for the first one here. I'm going to use Notepad for that because it's very easy to show. So this one here is doing that. When you pick a start point, control is passed to the next getPoint function, this one. When you pick an endpoint, the point value stored in the end variable, and the result of this statement is examined by the next if statement, and control is passed to getDistance, and return to half variable. The getDistance function acts in a similar fashion when you pick a point on the screen or enter a numeric value. The result of the getDistance function is stored in the half-width variable. So it's stored in here, getDistance here. The program flow reaches the T nested deeply within the function. No other functions follows this, so the function ends, and the value T is returned. This is the T you see in the console window. So you're gonna see that after running, you see the T in the console window there. You need some way to return values from one function to another. One way to do this is to create a list of the variables retrieved from GPGetPointInput, as highlighted in the following code. Copy this version of GP into console window and press enter. You're going to copy that and put in console window and press enter. Here's an opportunity to try another feature of the console window. To use the console window history feature to run GPGetPointInput, you press tab. This involves the console history command, cycling through any commands previously entered in the console window. If you go too far, you can press Shift Tab to cycle in other direction. When you see GPGetPointInput at the console prompt here, you can press enter to execute the function once again.
respond to the prompts as before. So here in the prompt, got start at the start point of the path, end point of the path, half width of the path. The function return a list containing two nested lists and a real floating point value. The return value looks like the following. These values correspond to the start point, end point, and half width variables. Interesting. So that's it for examining the GPGetPointInput function. In lesson 2, examining the GPGetInput function. Tutorial Garden Path VisualLISP IDE. Lesson 2, using VisualLISP Debugging Tools VisualLISP IDE. Examining part 4, using Association List to bundle data. The previous example works, but you can do better. In the next exercise, you will build an association list or a short list after the list function that deals with association list. In an association list, the values you are interested in are associated with key values. Here's an example association list. So here you got this. In the sample association list, the key values are the number 10, 11, and 40. These key values serve as a unique index within the list. This is the mechanism AutoCAD uses to return entity data to AutoLISP if you access an entity form within your program. A key value of 10 indicates a starting point. A key value of 11 is typically an endpoint. What are the advantages of an association list? For one thing, unlike a regular list, the order of the values returned does not matter. Look at the first list again. So you got this, and this. Look at the return values. It is not apparent which sublist is a start point and which sublist is the end point. Furthermore, if you modify the function in the future and any other function that relies on data returned in a specific order may be adversely affected. Using an association list, the order of the values does not matter. If the order of an association list changes, you can still tell which value defines what. For example, an 11 value is still an endpoint, regardless of where it occurs within the overall list. So here we got order of a list has been modified, and we got here 10 is normally starting point, 40 is kind of a distance, and 11 is normally an endpoint. So that's it for using association list to bundle data, which is part 4 of lesson 2 using VisualLISP debugging tools. Lesson 2 part 5, putting association lists to use. When you use association lists, you should document what your key values represent. For the garden path, then the key values of 10, 11, 40, 41, and 50 will be the following. 10 indicates the 3D coordinate of the start point of the path. 11 indicates the 3D coordinate of the end point of the path. 40 indicates the width, not the half width of the path. 41 indicates the length of the path from start to end, and 50 indicates the primary vector or angle of the path. The following is an updated version of GPGetPointInput function. Within it, an AutoLISP function called cons, short for construct a list, builds the key sublist that belong to the association list. Copy this version to the console window, press enter and run GPGetPointInput again. So we're gonna copy that, put in here VisualLISP console. I'm gonna just run that. So notice that when building, I'm gonna put in here to see how the function is look like. Now when building the list, the program converts the half width specified by the user into a full width by multiplying its by value by 2. The console window shows output similar to the following: GP get point input, and we got that. So let's come back to the program again. You're gonna tap the tab and the tab, and we run this. So here GP get point input, enter, and the AutoCAD is jumping in. We press the start point, the end point, half of the width is like 3, and then the return is looks like that. But what's the difference here? We got 10 for start point and 11 for end point, 40 for the distance, not the half distance, 50 is the angle start point to end point, and 41 is the distance from start point to end point. And let's see the code how it looks like. So we can see that we get the start point using get point and assign to start point, get the end point and assign to end point, and get distance assigned to half distance. Then we're gonna just construct a list, and the list is a constant. Here is 10 is start point, 11 is end point, 40 is half width multiplied by 2, and 50 is the angle start end point, and 51 is distance start point and end point. So that's it for putting association lists to use in AutoLISP, which is section 5 part 2, lesson 2 part 6, storing the return value of GP get point input in a variable. Now trying something else. Call the function again, but this time store the return value in a variable named GP path data. To do this, enter the following at the console window. So you're gonna do set GP path data as that function. Gonna run that, and we've got start point, end point, half width. So to view the value of the variable you set, enter its name in the console window prompt. So just copy that and put it in console window prompt, and we're gonna get that exactly what we got just above. So VisualLISP return data like the following. And that's it for part 6, lesson 4, storing the return values of a get point input to a variable. Lesson 2, part 7, examining program variables. VisualLISP provides you with an entire toolkit of programming and debugging tools. One of the most valuable tools is a watch, which lets you examine variables in more details than appears in the VisualLISP console window. You can also watch local variables within functions as the function executes. To watch the value of a variable, you click on Debug and Watch from the VisualLISP menu. Debug, Watch. VisualLISP display a dialog text box title called Add Watch. Enter the name of the variable you wish to examine. For example, specify GP path data, the variable you just set from the console window. VisualLISP display a watch window. VisualLISP display the value of the variable on a single line within the watch window. The base window shows in the illustration. In this case, the value of the variable is a long list, and you cannot see its entire value. You can resize the watch window by dragging its border, but there is a better alternative. Double click on the variable name in the watch window. This opens an inspect window. The inspect window indicates the data type of the variable are inspecting, in this case a list, and the value of the variable. for list, inspect display each list item on its own line. Double click on the line with the association list key is 11. VisualLISP will open another inspect window. When you are done inspecting variables, close all the inspect windows but keep watch window open. And that's it for examining program variable part 7, lesson 2. Lesson 2, part 8, revising the program code. Now that you have seen how to use association lists in AutoLISP code, you can use this method in writing the completed version of the GPGetPointInput function. Using the following code, replace or modify the version of GPGetPointInput you previously saved in GPMain.LSP. If you need or want to type code into GPMain.LSP rather than copy it from another file, you can save time by leaving out the comments. All lines that begin with semicolons, but don't get used to the idea of writing code without comments. So we can copy the whole code there, and we're gonna define get. So we got that. We just change only the getPointInput function. You're gonna see that function getPointInput function. Description: this function asks the user to select 3 points in a drawing, which will determine the path location, duration, and size. If the user responds to get functions with a valid data, use .pt and npt to determine the position, length, and angle at which the path is drawn. Return the value of each. This function is a list consisting of starting point, ending point, width, length, and angle path. List of 3 reals, a point denoting starting point of garden path. List of 3 reals, a point denoting ending point of garden path. Real number denoting boundary width. Real number denoting boundary length. Real number denoting the angle of the path in radians. That's the very detailed description of the function. That's very good. So here we got the defined function getPointInput, and we have the input parameter, which is start point, end point, and half width, which is all local variables. And we have a if setQ is this is for assigning value to a variable. This is a variable name, and this variable name will be getting the information from that getPoint function. Similar if set endpoint, and similar set half width we're gonna get from distance. So half width is gonna get from distance, but down there is a list construction with the association code. So it's gonna be construct the 10 is the start point, 11 is end point, 40 is the width, not the half width. So we need to use a multiplication and half width on the left and the value to multiply width on the right. And we got constant 50 is angle, constant 41 is distance from start point to end point. And that's it for the function. You can save it, come back there. So next you need to update the main function cpath in GP. Modify it to look like the following code. So here the main function. So in the main function gpath there, you're gonna change that part of the function from here to down there. Is that correct? End of the program, basic like end of defined function. That's the new here exists quietly. If you are copying and paste the code and adding the following commands as a header preceding the gpath, so we need that for the main part of the function. So we're gonna have that. So this function is gonna function gpath. the main garden path function. Description, this is the main garden path function. It is a function, meaning that this is to return to an AutoCAD command called gpath. This function determines the overall flow of the garden path program. That's the description. The GP path data variable is an association list of the form. So you got 10 is starting point, 11 is ending point. 40 is the width, 41 is the length, 50 is path angle, and 42 is tile size, 43 is tile offset, and 3 is object creation style. 4 is polyline border style. Function gpath is the main program function and defines the AutoCAD gpath command. So you got define function gpath, and the input is GP path data. And you're going to ask the user for input for the first path location and duration, then for path parameters. Continue only if you have valid input. Store the data in GP path data. If you and then you're going to set the GP path using getPointInput function, and that getPointInput function is actually the user-defined function before getting into this function. And then if something, you're gonna get get dialog input, and then you're gonna program this. At this point, you have valid input from the user. Draw the outline, storing the resulting polyline pointer in the variable called polyline name. Then you set polyline name is actually raw outline, and you print out the GP draw outline function, return that value, and you print out the polyline name, and you close that, and you go, congratulations, your program is complete, and you end the program, and you print out function cancel if it's not. So if it's finished, you print out it's finished, and you call the program, and if it's not, just print out the function is cancelled. So it's just like this is true and this is false. If it's not true, it's gonna be false. The similar in this if, you're gonna have the if here, you're gonna get that dialog input, and this is the end. If the input is not working, it's gonna and it's gonna print out that the function record and end the if function. Similar, if the get point is not working completely, then it's gonna print out incomplete information to draw a boundary. Then it's gonna end the function using a parenthesis, and then it's gonna just exist quietly and then end the define function. So to test the code revision, you save the update file, use the check feature to search for any syntactical errors. So you're gonna make it to check text in this editor. Got check done, nothing is wrong there, so that's all good. You format the code to make it more readable. So I'm sure that's a format edit, format selection, so hopefully it's more readable. Then you load the code so that VisualLISP refine the earlier version of the function. So what you need to do is just load the code again. So in order to load the code, just go to Tools, called Load Text in Editor, and you got that is loaded. To run the program, you type in that CZgraph, and it's gonna bring you. So if the program does not run successfully, try fixing it and return it again. Repeat until you are too frustrated to continue, or if all else fail, you can copy the correct code from the tutorial VisualLISP lesson 2 directory. But here for me it's working pretty well. So it's gonna ask me to start the point at the path there, end point there, and the width there. Not very bad. The function GP get dialog input will get user choices to a dialog. We're not gonna work with it now. This function will draw the outline the following outline of the polyline and return a polyline entity name and pointer. So we can see that this function is gonna do that. So congratulations, your program is complete. So after complete, we got that. So that is it. That is it for revising the program code, which is part 8 of lesson 2 using VisualLISP debugging tools. Lesson 2, part 9, commenting program code. VisualLISP treats any AutoLISP statement begin with a semicolon as a comment. The last two code examples contain a lot of comments. A comment in an AutoLISP program is something you write for yourself, not for the program. Commenting code is one of the best programming practices you can establish for yourself. Why write comments? To explain the code to yourself when you are editing the program 9 months in the future or later, adding all those features your user has been asking you about, memory phase, and the most apparent sequence of the function can easily turn into an unrecognized tangle of parentheses. To explain the code to others who inherit the responsibility of updating the program. Reading someone else's code is an extremely frustrating experience, especially if the code contains very few comments. VisualLISP contains some utility that help you as you comment your code. Notice some comments in the example begin with 3 semicolons, sometimes 2, and sometimes just 1. To save space, the remaining code example in this tutorial do not include all the comments in the sample source files. It's assumed that you have already established the beneficial habit of extensive commenting and will do so without any prompting. So that's it for commenting program code, which is part 9 of lesson 2. Part 10, setting a breakpoint and using more watches. A breakpoint is a symbol point you place in a source code to indicate where you want a program to stop executing temporarily. When you run your code, VisualLISP proceeds normally until it encounters a breakpoint. At that point, VisualLISP suspends execution and waits for you to tell it what to do. It hasn't held the program for good. It has placed it in a state of suspended animation. While your program is suspended, you can step through your code function by function or expression by expression. Resume normal execution of your program at any point. Alter the value of variables dynamically and change the results of the program being executed. Add variables to the watch window. So that is setting a breakpoint and using more watches. Part 10, lesson 2. 2.11, using the debug toolbar. The debug toolbar contains several tools you will employ as you work through this section. By default, this toolbar is attached to the View and Tools toolbars and appears as a single VisualLISP toolbar. The debug toolbar is the leftmost set of icons. So most of the items on the toolbar are inactive until you run the program in debugging mode. That is, with one or more breaking points defined. So if you have not done so already, detach the debug toolbar from its position at the top of the screen. So you're gonna have the detach here, that the watch. You should have a debug toolbar somewhere. I'm gonna get the debug toolbar. So if it is here, I'm gonna make it on top there. So this is the debug toolbar. I'm gonna put it out there. It's a called debug here. So I'm gonna put it on top there. Okay. So the debug toolbar is divided into 3 main groups of buttons, each consisting of 3 buttons. When you run a program in debugging mode, the toolbar looks like the following. The first 3 buttons allow you to set to your program code. The next 3 buttons determine how VisualLISP should proceed whenever it has stopped at a breakpoint or an error. The next 3 buttons set or remove a breakpoint and add a watch and jump to the position within your source code where the last break occurs. The last button on the debug toolbar is a step indicator. It does not execute any function but provides a visual indication of where your cursor is positioned as you step through your code. When you are not running in debugging mode, this function appears blank. To set a breakpoint in the VisualLISP editor window containing GP main libs, position your cursor just in front of the opening parenthesis of the setQ function of the following line of code. Within the GP getPointInput function, so you get setQ half width, get distance and width path. Then click the mouse one. The position is illustrated in the following screen snapshot. So I'm gonna, in the VisualLISP editor window containing GP main libs, position your cursor just in front of the opening parenthesis and at the setQ function for the following line of code within the getPointInput function. So I'm going to go to that one. Okay, so I'm going to just put click the mouse one. The position is illustrated in the following screen snapshot. So it should be there. Yep, that position. Yep, yeah. And with the text insertion point set, choose the toggle breakpoint button on the debug toolbar. So when you click on that and that you toggle breakpoint. So you put that there, you toggle the breakpoint. So the toggle breakpoint button acts as a toggle alternating between on and off status. If there's no breakpoint at the cursor position, it will set 1. If there is any breakpoint there, it will remove it. So choose the local active edit window button toolbar to load the file. So you set that, and then you choose the load active window toolbar. So how to load it? Put here. We'll just go to and load text in editor. So which one is I think this one, load active edit window. Okay, and then we're gonna run that function again. VisualLISP execute the program normally up to the breakpoint. In this case, it will prompt you the first 2 points and the start point and end point of the path. So then we specify the start point and end point when prompt. So start point, end point, half width, and it stopped there. So I think I didn't set that correctly. I'm gonna break that again. I'm gonna set that here. I think so. I'm gonna break there. How about set inside here? Illegal position breakpoint. So I'm gonna break it there at the end of set endpoint. I think it'll be good. So I'm gonna run this again. I'm gonna load the active that is already load. I think it already load. So I'm gonna. There's something going on there. Okay, so actually it's working now. So there are a couple of things to notice. The cursor is located right at the breakpoint. Okay, that is the last breakpoint. This is my difficult to notice, so VisualLISP provide another clue. In the debug toolbar, the step indicator icon display a red I-beam cursor in front of a pair of parentheses. This indicates the VisualLISP debugger is stopped before the expression. That one. I think that's one. So we're gonna how to break it. Learn from that. Okay. We have 3 paths. So 3 button remove, break, and watch. Okay. So how to stop it? in order to stop that, you're gonna go to there and quit current level. Okay, so it's quitting now, and gonna set that one. You're gonna load active edit window again. I'm gonna press tab, gonna run that one, and it break there. So it allows us to go to that. So that's the way that we can break. And that's it for using for 2.11 using the debug toolbar. 2.12 step into code. There are 3 buttons that you can use to step through your code. These are 3 leftmost icons on the debug toolbar. They are here. In sequence, they represent the following actions. Step in the highlighted expression. Step over to the end of the highlighted expression. Step out to the end of the function where you are currently stopped. To step through the code from breakpoint, click the step over button. Let's click on that. After you click on the step over button, control passes to AutoCAD, and you are prompted to specify width of the path. Okay, interesting. Yeah. Okay, so it will ask us to control the width of the path. Reply to the prompt. After you specify the width, control passes back to VisualLISP. Notice where your cursor is and what the step indicator button shows. VisualLISP evaluates the entire highlighted expression, then stop at the end of the expression. Click the step over button again. VisualLISP jump to the beginning of the next block of code. Highlight the entire block, interesting, and click to step into or not step over button. Step into button. Note, during this exercise, you make an incorrect selection and skip a step or two. You can start the exercise very easily. First, choose the reset button from the debug toolbar. This will terminate the execution of any VisualLISP code and reset the VisualLISP system to the top level. And next, start over step 1. So how to reset the button? You got here, continue, quit, reset. Okay, you're gonna get right to the top. So refresh, and that is the point that you set for the breakpoint. I'm gonna total that. I'm gonna choose that breakpoint. Okay, so let's say load active edit window. So I'm gonna load. So in here, load active edit window, and I'm gonna call the function there, and it's gonna ask me start point for a path, and because the break is there, so it's gonna stop, and I'm gonna click step over, and it go to the next path. And if in here it's gonna ask me, it seems not that it didn't ask me anything. A step. Okay, so it's if I step 2 step, it's gonna ask me end point of path, and then it's gonna ask me next that point, and it's gonna go to the end of that, and then go to next and to next, and it's gonna done, and it's just done for the function. And next, okay, it's gonna go to that one, and you're gonna go next, you go to set IP, okay, and then it's gonna run the whole GP get dialog input, and then you're gonna see something on the screen. Not yet, so click on that, and you see something on the screen there. So you're gonna put an alert there in there. Where is that function? GP, okay, that one, return. So I'm gonna okay it. So this function will draw the outline. That one, congratulations, your program is complete. And at the end of if, then we got over, it's okay, so nothing for now. But how about if we, yeah, so that is, and then done. And because we assign the variable to this GP path data, and we run that, we're gonna have that variable looks like that, all the information inside it. And that is for stepping to your code, which is part 2.12 Tool 13, watching variable as you step through a program. While you step through your program, you can add variables to the watch window and change their values. If you do not see the watch window, simply choose watch window button on the toolbar to bring it back. So here is the watch window. If you don't have that, maybe just get into the debug add and choose that and OK. So if your watch window still contains the variable GP path data, click to clear the window. Button display at the top of the watch window. So that add one is a clear window. To add variables to the watch window, you double click on any occurrence of start point in the VisualLISP text editor window. This is the name of the variable whose value you want to check. So click the add watch button in the watch window, or right click and add watch. So I'm gonna right click on I think from the beginning here, right click on the start point and add watch. Okay, that's interesting. So you're gonna watch all the variable like start point, end point, and half width. If you are debugging a program that is not working correctly, use breakpoints in combination with watches to make sure your variable contains the values you expect. If a variable does not contain the value you think it should, you can change the value and see how it affects the program. For example, say that you expect the half width value to be a whole number, but because you were not carefully about picking the point during the input selections, you end up with a value like 1.9. So to change the value of a variable while the program is running, enter the following at the console prompt. So set half width is that. Note that the value in the watch window changes, but can you be sure the new value will be used when the width sublist for the width is created in the association list. Add one more expression to the watch window to test this. Click debug and watch last evaluation, the VisualLISP menu. This adds the variable name last value to the watch window. So last value is a global variable in which VisualLISP automatically stores the value of the last expression evaluated. Step through the program choosing either the step into or step over button until the expression response for building the width sublist is evaluated. So the width sublist is evaluated. That's interesting. The code for this action is this one. If you overrode the value of half width as specified, the evaluation of this expression should return 40 in the watch window. So let's do it again now. Okay, so I'm gonna set and I'm gonna start doing that, and I'm gonna start debugging. So how can I do that? Because the point is there. What I'm gonna do now, how can I start debugging? So what I'm gonna do is I'm gonna run that, and I'm gonna click 1, and then you see that the start point has some coordinate there. That's interesting. The last value is the same as start point, but end point and half width has nothing. So I'm gonna step over, step into. What is step into? That is step into, continue to step into, not working. So I'm gonna step over. When I do step over, it's gonna ask me the endpoint. I'm gonna choose the endpoint, and now we got the endpoint got coordinate now. Endpoint got coordinate now, and then I'm gonna step over to the next part, which is this point, and this point is still not yet running anything. I'm gonna go step over, and will ask me the width, the half of the width, and now we got the half of the width as well. Half the width, but the last return is not that. So what is the last point you to here? So you can see that it's already returned the width as well. So I'm gonna set half width to be that to see how it works. And after setting that, you can see that half width now become 2. Okay, so I'm gonna watch the last evaluation. I think this is what's now last break. So click debug and choose what's last evaluation. Yeah, it will add the last variable in there. Okay, that's alright. Got that last variable. I got it. I did it. And step through the program and choosing the step into over button until patient responsible with sublet evaluated. Now I'm gonna change this to that. I'm gonna put in there. And now 40 is 4. Okay, so you can run it there. If you overrode the value half width, spend that, and you're gonna get that. So that is the way it's working when we work to watching the variable as you step through the program. So again, if we want to watch a variable, we just right click on the variable and then click to add watch. How about this one? This one is not a variable. It's not a variable at all. It's a list. It's association list code. And that is for the section 213, watching variable as you step through a program. 214, stepping out of the GPGetPointInput function and into GP main. There is one more point to illustrate what happens to the value of the local variables into GPGetPointInput after you exit the function. To exit GPGetPointInput and return control to CGraph, click the StepOut function. So here is the StepOut function. So if you are there and then get there, you're going to get into that main function. VisualLISP will step to the very end of that GetPointInput function and stop just before existing, and click the step into button. Oh really? Control return to GMain and the function that call GetPointInput. Examine the value of the variables in the watch window. Because they are variable local to GPGetPointInput function, endpoint and start point are nil. Wow, it all delete the local variable. Interesting. VisualLISP automatically reclaim the memory occupied by these variables. Normally, the third local function variable half width also contains a value of nil, but due to debugging activity, it is overwritten globally in the console window and still processes the value 2.0 in the watch window. Also, the global last value variable display the association list constructed by the GPGetPointInput. So your first debugging section is complete, but do not forget the program is still suspended animation. So to complete this selection, click on the continue button on the debug program. Add one. Respond to the prompt. This run the program to complete. Click the debug clear all breakpoint from the VisualLISP menu. So go to debug, clear all breakpoints and choose yes to the prompt. This removes all the breakpoints within your code. Yeah, debug, clear all breakpoints. Remember that you can remove individual breakpoint by positioning the cursor at the breakpoint and choosing the total breakpoint button. So you can click whatever you want and click in here, and you can click again to remove it. And that's it for 214, stepping out and stepping in. 215, wrapping up lesson 2. So in this section, you learn about local and global variables. You set and remove breakpoints in the program. You step through a program while it was executing. You watch and dynamically change the value of the program variables during execution. You show how local variables are reset to nil after the function that defines them completes its run. The tools you learn in this lesson will be part of your daily work if you intend to develop AutoLISP application with VisualLISP. That's it for lesson 2, and this is